Today we are going to see about instrumentation amplifier, and we are using the trainer kit model number ITB09, and this is the instrumentation amplifier circuit diagram. You can see the same circuit diagram is in the kit we are having. The first amplifier is non-inverting amplifier, and this is T1 or V1. And the second amplifier is inverting amplifier. This is IC 741. It is T2 is V2, and the third is the instrumentation amplifier, and this is the internal switch, and this is this S2 switch. If you make the switch in this direction, we can calculate for 10 gain, and if you turn the switch in R2 direction, we can calculate for 100 gain. And this is the potentiometer. We can adjust from 0 to 50 millivolt. Amplifier is used to amplify the input signal, and we are going to calculate the common mode reduction ratio, that is CMRR. For a good amplifier, the value of CMRR should be high. Here we are going to cross-check the input, that is practical value and theoretical value are the same. The main use of amplifier is to amplify the physical quantity of inputs like force, pressure, velocity, etc. Now going to the experiment. First of all, put the potentiometer in 0 position and switch on this. Now you can see the display. It will be 0. Now we put the switch 2 in this position, that is 10 gain, and this is in position, internal position, and by adjusting the potentiometer, you keep the voltmeter to 10 millivolt. And you can read the output voltage in the display is 0.08. That is, you can write that is V1 is equal to 10 and V2 equal to 0 you can put, and VO practical, that is kit output display, that is 0.08. You can see V1 is 10 and V2, we have taken V2 as 0, and the display of the kit output V out is 0.08 or 9. By using the potentiometer, increase the voltage to 20, that is input to 20 millivolt, and you can see the display is 0.19. So we have taken the reading for 30, V1 equal to 30, that is input, and we got the practical out is equal to 0.28. and for 40 0.38 and for 50 0.48. And next we are going to do this same for 100 gain. Now for 100 gain, switch the S2 switch to R2 position, and same the adjust the potentiometer to 10 in the input. We are getting 0.92. So for 100 gain, the switch is in position, initial position, and S2 is in R2 position, and you can see it is 10. The input is 10. The output, practical output is 0.92. Similarly, for 100 gain, we have taken for 20, that is input V1 equal to 20, and we are getting the V0 practical output equal to 1.85, and for 30 2.78, and for 40, that is 100 gain 3.71, and for 50 4.53. Next we should calculate this VD and gain and V0. VD is nothing but V1 difference V2. So 10 means only 10, 20 means 20. Now by using the formula you can calculate for 10 gain and 100 gain. For 10 gain you can see A equal to V0 by VD. So 0.08 divided by 10, that is 0.008, and VO equal to A into VD. So 0.008 into 10, that is equal to 0.08. For 100 gain, you also A equal to V0 by VD, that is 0.91 by 10, that is equal to 0.091, and VO equal to A into VD. We know A equal to 0.091 and VD equal to 10. So 0.91 into 10, that is equal to 0.91. For the same formula, by using the same formula, we have calculated for 0.19 in 10 gain till 50, that is 0.48, and also for 100 gain we have calculated. You can see the for 0.91 we are getting A equal to 0.091 and V not equal to 0. From this we can conclude that is the practical value we got in the display unit and theoretical calculation are the same. So and this is the model graph for 10 gain, and you can also draw the model graph for 100 gain instrumentation amplifier characteristics result. Thus the characteristics of 10 and 100 gain instrumentation amplifier were studied. Thank you for watching this.